Alright, so we will be discussing this question. And in the question, it's about tables in an exam hall, and the probability that one is wobbly is 15%, which I will straight away convert to 0.15. Okay? Please note that in this question we are talking about something being wobbly or not wobbly. These are the only two possible choices. Therefore, we have basically an either or situation, which signifies that I am looking at a binomial distribution of my random variable x. In this case, with n equals 6 and the probability 0.2, 0.15. This is sometimes the hardest part of the question. Read the question again. It doesn't say anywhere in this exam question that you need to be using the binomial distribution. In my experience, that's the hardest bit that students actually struggle with, is identifying what you need to do in this question, which is why I focus on this either or. If you see something like this, there's either one choice or the other, and they're mutually complementary and exclusive, then this is a good sign that you're looking at a binomial distribution. In this case, we have 6 desks in a row, and one of them, we're looking at the probability of more than one of them being wobbly. So maybe 1 or 2 or 3 or all 4 or possibly all of these 5 here, in any order, of course. Okay, so typical binomial situation. So what we're looking at is, we'll write P of x, capital X, larger than 1. That's what we're looking. This is saying I'd like my random variable to be either 2 or 3 or 5 or 6. Okay, all of these added together. So far in an exam situation, by stating this, which you need to do, you have one method point, and here you have another method point for identifying this typically. Okay, possibly writing this out, but really this is best looked at the reverse, that the probability here is 1 minus P of x less or equal to 1. Okay, because if it's not 2, 3, 4, 5 or 6, well, if it is 2, 3, 4, 5 or 6, it is not 1 and 0, basically. Okay, this will be quicker to find out than all of these. So if I want to, I could rewrite this like that. I could split this up. This is P of x, capital X equals 0, plus P of x equals to 1. This is what this means, less or equal to 1. So there could be no desk wobbly or one desk wobbly. If I want to split it up like this, okay, in this case, I will be using binom PDF on my calculator, right? And I'll repeat this for this one and for that one. However, if I go for this line here, I basically need to add all probabilities until 1, and so in fact I can use 1 minus, okay, and this is not really part of that working, but I'm just explaining, binom CDF, okay, for cumulative, so from 1 all the way to, from 0 all the way till 1, okay, with n being 6, my probability 0.15, and my highest number being 1. So I'm accumulating from 0 all the way to 1, these two items. Okay, remember the calculator expects the input NPR. Right, and if I type all this in to my calculator, Okay, binom CDF 6, 0.151. Also subtract that from 1. I get approximately 0.224. Give your answer to 3 significant figures. Right, this is the probability that there is one or more, sorry, that there will be more than one wobbly disc. In other words, 2 or 3 or 4 or 5 or 6. Over to question B. So B is much simpler. This time we want the probability that x is exactly 1. So I would get this by doing binom PDF with this information here. That's in fact corresponding to just this bit here. I can also do it by hand if I want to do. Let's do it one more time together. Okay, I need n over r. So n is 6, r is 1. Then I need the probability 0.15 to the power of r, that's therefore 1 times the complement of the probability 1 minus 0.15 to the power of 6 minus 1, 5. And I could type this into the calculator. You might want to do this as an exercise to check you get the same thing as that. Okay, that's it.